Hello, everybody. In my math class, we are almost done. It is the end of the quad, and this is the 30-question quiz. We're almost there and almost done. This is going to test all of your knowledge on all of the 10-question quiz style questions that we've had. There's going to be a practice that we're going to review, and then you're going to have a new one with different numbers to make sure that you can do questions with different numbers. But for now, I'm going to go through and show you each question here. You're going to want to speed up this video and cut ahead to different sections depending on where you want to be. So, first one, question one is adding two numbers. So, you can do that on your calculator. So, option A here is just do it on your calculator. You need to be able to know how to do that, punch them in, add numbers. Option B, if you want to give yourself a little push, you take the larger number, you put it on top, and you take the smaller number, you put it on the bottom, and you line up from the right-hand side. So, 7, 8. So, these are the two numbers, and then to add them up, I add the right-hand side first. So I start over here, I go 0, and I carry this 1 because it made 10. Then 6 plus 6 is 12, plus 1 is 13. I write the 3, but I can't write two digits down here, so I carry this. 7 plus 7 is 14, plus 1 is 15. Carry the 1, that's 16. That's going to be 17. Carry the 1, and that's 10. So 10, 7, 5, 3, 0 would be the answer to this. To question number 1. Again, make sure the digits are lined up on the right-hand side if you're going to do it that way. Let's move on to question number 2. Question number 2. We've got 371, and we're going to subtract 582. We can line up the same. Again, you always have the option to do a calculator here, but when we're going to subtract, we end up having to do a couple different things. We're going to have to go into the negative here. And so setting it up like this actually doesn't work. We're going to reverse it. So we know that this number is bigger than this number. So we're going to get a negative number. So no matter what, when we have a number spit out at the bottom, we're going to make sure that is negative out in front. So let's just do it easier. Put the bigger number on top and the smaller down below, but we're going to switch it and flip the sign of it down here. So when I subtract that, I'm going to get a 2. When I subtract that, I'm going to get a 1. When I subtract that, I'm going to get a 2. And I know that because I flipped these, I needed to flip this sign. This is a negative now, so negative 212 plus 582 on the negative and positive. So if this is 371 and I'm subtracting negative 212 to go from on the positive end here, 371, to subtract 582 takes us past 0 into the negative, and it goes to the negative 212. Again, how do we do that? We took the larger number and put it on top, but we had to then flip this sign so that the final number became negative. That's kind of a trick rather than doing the more complicated math. Hope that is useful there. So for question 3, I always appreciate for question 3 doing number lines. So with number lines, we start with 0 in the middle. Now, negative 9. Where is negative 9? Negative 9 is going to be down here. Now, when I add 2, this is the positive direction, this is the negative direction. When I add 2, I'm going 1, 2 steps over there to negative 7. So that's the add 2. And then minus 5, I have to go back on this line 5 direction this way. But see how this is getting bigger here? It's not actually getting smaller. I'm moving in this direction, so I'm going to get to negative 12 by going that jump. And then negative 3, another jump, is going to be getting even more negative. It's pushing it down this side of the number line. So that's going to be negative 15. So the answer here is negative 15 overall. That's how we move in the negative space. And if we're adding, we're going that way. If we're subtracting, we're going that way. So that is question 3. Question 4 and 5. 4 and 5 we've been doing a lot of. Remember that when you take any number, 8, and you times by 10, you just add 1 0. So that would be 80. Now if we times by 100, it's going to be 800 because there's 2 zeros. The other way to think about this is moving the decimal point. So I moved it once and then I moved it again twice. So similarly, if I had 8 and I divided by 100, I would have to move the decimal point once and twice. That becomes a 0. So I have 0.08. In the question that we were given, we're given 8.08. So the number of zeros is the number of times you move the decimal point. So 0.08 times by 1,000. Well, that's 3 times that we move the decimal point. So we move it once, twice, and again. There's a 0 there. There's a phantom 0. So we have 8,080 by timesing by 1,000. Now, what if we divide that by 1,000? Then we have moving the other direction. So 8.08. That decimal point moves once, twice, 3 times, and we draw those zeros. So it is 0.00808 is that divided by 1,000. Those two go together. The number of zeros is how many times you move that decimal point. Hope that helps. Next question. So perimeter and area. So question 6 and question 7. We have a shape in this case. It's 8 meters by 12 meters. It's a rectangle. So the perimeter, remember, perimeter is walking your way all around the outside. So if I start here and I walk 12, I walk 8, that's 20. If I walk 12 again, that's 32. And if I walk this, that's 40. So the perimeter equals 40. And don't forget units here. Units are 40 meters. Now the area is different. Area is base times height, or length times width. So it's 12 meters times 8 meters. And so to just do some quick math there, 12 times 8 is 16, and this is 96. So 12 times 8, base times height, is 12 times 8, and that's 96. Now what do we do with units? There's these meters. And we've times 2 things by meters, which means we have 2 meters or meter squared. So the answer is 96 meters squared. That unit is extremely important with area. In perimeter it was meters. In area it was meters squared. So that's how to do that kind of problem for question 6 and 7. For question 8. For question 8, we're doing volume. And we're doing volume of what's called, in a fancy way, a rectangular prism. Basically means a box. On the box here, I got 3 centimeters. I got 1 centimeter high, and then deep, this box is 5 centimeters. Well, volume equals base times height, and that's exactly like area times length. So length times width times height, or length times base times height, however you want to name those different pieces. The volume in this case, the base is, let's say, 3 centimeters. The height is 1 centimeter, and the length back is 5 centimeters. So 3 times 1 times 5, the volume is 15. Now what do we do with units? Units are all in centimeters. Because we're multiplying them all together and we're dealing with volume, you have to have this unit called a cube. So cm to the 3. That to the 3 is really important on those units. And if you forget that, you lose part marks. So that is the volume, centimeters cubed, and we have 15 centimeters cubed for this particular question. All right, question 9. Question 9, we've got certain number of centimeters equals 0.8 kilometers. So let's think about this, and we can convert back one step at a time. I give you a hint there that there's 100 centimeters in 1 meter, and that there's also 1,000 meters in 1 kilometer. So let's just think, we're dealing with less than a kilometer, so we're going to deal with less than 1,000 meters. So let's start there. So if I have 0.8 kilometers, well, that is the same thing as taking this number and timesing by 1,000. So what's 0.8 times 1,000? Well, if we times 1,000, we get 800 meters. Okay, cool. So 0.8 kilometers is 800 meters. Okay. So then how do we get from meters to centimeters? Well, we take the number of meters and we times by 100 to get centimeters. So if I have 800 meters and I'm going to do something to it to get the number of centimeters, I have to times by 100. So again, think about these zeros, right? We add 2 more zeros on here, so we've got 800 plus the 2 zeros there, so that's 80,000 centimeters. 80,000 centimeters is the same thing as 0.8 kilometers, so I can say 80,000 centimeters is the same thing as 0.8 kilometers. So you can use those conversions to slowly move between meters, centimeters, and kilometers. All right, that was question 9 and question 10. We got beats per minute. We got 300 beats per minute. Well, then we have beats per second. And we don't know how many. How much is this the same? So let's think about this. 300 beats per minute means that that's in 1 minute, I hit this 300 times. I hit 300 beats. In 1 second, that's 60 times smaller, which means that this has to get smaller. So because the time interval is smaller, the amount of beats that happen in that time interval is smaller. So we need to make this smaller. So how do we do that? Well, to go from minutes to seconds is 60, right? There's 60 seconds per minute. So, but how do we make this smaller? We can't subtract 60 or add. We need to do something that actually changes this number more deeply, and that's where we divide. So 300 divide by 60. Again, if I just do some quick math here, that is just 5. So 300 divides 60, you could do that on your calculator. This is the same as 30 divided by 6, which is 5 beats per second. So that's the answer there. 5 beats per second is what we're looking for question 10. All right, we're a third of the way there. So question 11, 12, 13, and 14. Each one of these is actually, for fractions, 7 over 8 plus 1 over 2. This is going to be 7 over 8 minus 1 over 2. This is 7 over 8 times 1 over 2. This is 7 over 8 divide by 1 over 2. Each of these is different, and I want you to treat the top ones, the subtract and add, differently than the multiply and divide. The multiply and divide are actually easier. For subtract and addition, you have to have the same bottom. No matter what you do, those numbers at the bottom need to be the same. So if that's 8 and 2, we have to change it. We have to do something. What do? Well, we have to scale up this second number in this case to be the same. So how do I do that? 2 changes into 8 by multiplying by 4. So 2 times 4 is 8. So I have to do the same to this. So this actually turns out to be 7/8 plus 4 over 8. How did I get 4? Well, I multiplied the bottom to get 8, and I multiplied it by 4, so I have to multiply the top, and 4 times 1 is just 4. So now that the bottoms are the same, I can just add, and I only add the tops. So 7 plus 4 is actually 11 over 8. The bottoms stay the same, you'll realize there. So 7 over 8 plus 4 over 8 equals 11 over 8. That's the answer there. And what do we do here? We do the same thing. So we say 7 over 8 minus, this is still the times by 4 because we want to make the bottoms the same. So we're going to have minus 4/8 equals, we just change the top. 7 minus 4 is 3. And the bottoms, will those stay the same? So you can see how addition and subtraction are really similar. You just have to make the bottoms the same. Multiplication and division, the bottoms don't have to be the same. It's actually easier. We go straight across. And when we go straight across, 7 times 1 is 7. 8 times 2 is 16. And that's multiplication. Now what do we do for division? It's slightly different. There's one extra change. It's almost the same as this. But 7 over 8 divide 1 over 2 is the same thing as 7 over 8. We leave that first number, we change it to multiply, and we go 2 over 1. So 7 over 8 times 2 over 1 is the same thing as divide 1 over 2. I flipped that second number and changed it to times. So when I did that, then I just multiply across like I did up here. I go 7 times 2 is 14. And I go 8 times 1 is 8. So see how these changed? Because that second number flipped in the division. So then the bottom, or the top got bigger in this case, and the bottom got smaller. That's the case for this particular set of numbers. So I hope that's helpful there. All right, question 15. We are halfway there. Question 15. 3 squared. That does not equal 3 times 2. It is not 6. It is not 6. I need to repeat that over and over. It is not that. It is 3 times itself. No, sorry. 3 times itself. 3 times 3. And you do that 2 times. So 3 times 3. So if I were to make this 3 to the 3, it would be 3 times 3 times 3. Or if I were to make that 3 to the 5, it would be 3 times 3 times 3 times 3 times 3. So in this case, 3 to the 2 is just 3 times 3. And what do we know? Well, that's 9. You can do that on your calculator too. So these powers, these exponents are extremely important to make sure that we're okay with understanding them. So it's that thing times itself. That's for question 15. For question 16, we're using that same idea. 4 squared plus 5 squared equals, well, that's 4 times 4 plus 5 times 5. This is 16 plus 25. I did those separately. And 16 plus 25 is 30, 41. So the answer to that one is 41. So again, the squared means times itself, times that number that many times. All right, question 17, 18, and 19. These are conversions. So 1 over 1,000. How do we get to decimal? Well, we can do a couple things. First, you can use your calculator. And if you use your calc, then it just says 0.001. Another way that you can do this is understand that 1 over 100 is 0.01. So if you add another 0, you have to extend that one more time. But the easiest way to do this is just use your calculator. Now, the percentage is move the decimal point twice. So for the percentage, it's 0.1%. And that looks a little weird because you can actually have a decimal and a percent in the same thing. But for 1 over 1,000, the decimal point moves twice to get the percentage, and that's the first question. For the second question, we have 0.01 here. So what do? Well, we move that twice for the percentage, so we got 1% there. So we moved it twice to get to the percent. And then to get over here, we take this number, this percentage, and put it over 100. So 1 over 100 is the fraction. And for question 19, we were given 99%. Well, I moved the decimal point twice, so I have 0.99 there. 0.99 and 99%, same thing. And then to get over here, I take this number, 99, and I put it over 100. So those are the answers for 17, 18, and 19. For question 20, this word problem, I'm not going to write it out again. I'll just show it here. So, Jordy gets 90% of questions right. He normally takes a 10-question quiz, but today the quiz is 300% bigger. How many questions should Jordy get right on this new, longer quiz? Okay, so there's two different pieces to this. We see 90%. That's what he normally gets right. So 90% right. That's a thing that we know. And then we know that the quiz is 300% bigger. Now, do we know what it started at? Well, we know it started at 10. So if there was 10 questions, and now it's 300% bigger, we could do that on our calculator. So we could say 10 times 300%. We could also move that twice, and the decimal here is 3.00. So 10 times 3.00 is 30. So we know there's 30 questions. And hopefully you picked up this is actually real. This is a 30-question quiz. Now, if Jordy gets 90% of the questions right, what's 10% of this? Well, 30 questions times like 0.1 or 10%. Well, that's going to be 3 because we just moved that decimal point once. So if I have 3 questions that I got wrong, if I'm Jordy, that means 30 minus 3 is 27. So 30 minus 3 is 27, and I got 27 right. Or you could do 30 times 0.9, which would get you 27, and that would give you the answer there. So 27 is the answer. There's a couple different ways to get there, but if Jordy gets 90% right and the quiz is 30 questions big, you're going to get 27 out of 30 there. All right, we're 2/3 of the way there. We're going pretty quick, which is nice. Question 21. 21, 5%. Well, we know how to get 10%, right? So 10% of 180. 180 bucks. 10% is you move that decimal point or you knock off that last 0. So 10% is $18. So if 10% is this, 5% is half of this. And what's half of 18? Well, 18 times a half, or however you want to logic this out, is $9. So 5% is the same thing as $9 in this. So that's question 21. Don't forget how to do the 10 and then the 5%, which is just half of the 10. So 22. So question 22. 10% of 0.9. Now there's two ways to do this. The first one is going to be remembering the 10% rule is just move the decimal point once. So 10% of this is 0.09. Now if you don't remember that, or you see this and you freak out because it's a decimal, then you can just use math. So you can say 10%, you could do that on your calculator, times, remember of is times, 0.9. So either 0.1 times 0.9, or on your calculator, 10% times 0.9. Either way, it's going to be 0.09. So that is the answer to question 22. Remember to convert those units. Also, if we had a fraction, so if we had, let's say, 1/10 here instead of 10%, those are the same thing, then you'd have to convert that to decimal or a percentage. All right. That was question 22. Question 23. Question 23 is find x. So if we have 12 equals x over 3, you can use your logic here, and you could say some number divided by 3 equals 12. So some number, and I split it into 3 piles, equals 12. You might be able to just intuit that x equals 36. But how do we actually do the math there? We said we have to get rid of this bottom, and that means we have to multiply by 3 to cancel that bottom. So if we multiply this side by 3, we also have to multiply this side by 3. And that means 12 times 3 is 36 equals x. So whatever's on the bottom there, we have to multiply both sides by to get rid of it. And if there was something else here, let's say x plus 1, you'd still multiply by the 3, but then we'd have 36 equals x plus 1. Then we'd have to subtract 1 from both sides, and you'd get 35 equals x. So you do that stuff beside the x after you divided or multiplied by 3. So that's question 23. Question 24. 24 is 6x plus 2 equals 14. So how do we do this? In this case, we actually want to do the addition and get rid of that first. We want x by itself and all the x terms. And so to get to 6x equals, I have to subtract 2 here, which is going to cancel this stuff out. Now if I subtract 2 here, I have to subtract 2 here, and that's going to get me 12. Now 6 times something equals 12. You could do that 2 ways. You can just gut reaction that, or you can say, I'm going to divide both sides by 6, and I have to divide this side by 6 as well. 12 divided by 6 is 2. X equals 2 is the final answer there for question 24. So, question 25 and 26. I put these together because they're worth 2 marks. The first one is going to be the t-chart, and the second one is going to be the graph. So, the t-chart, we always make t-charts like this, x and y. We start with 0, 1, and 2, because those are easy numbers to go with. The graph here is y equals 3x minus 4. So we take the value for x and we plug it in here. So we'd have y equals 3 times 0 minus 4. Well, 3 times 0 is 0. And then minus 4 is just minus 4. So y equals minus 4 in that case. Then we do it for the next one. And we say, well, okay, what if x equals 1? Well, then 3 times 1 is 3. Minus 4, so 3 minus 4 is minus 1. So that's minus 1. Now what if x equals 2? So let's put in x equals 2 here. So 3 times 2 is 6. Minus 4, well, that's 2. And I bet you can see this pattern here. Negative 4, negative 1, 2. Even just by looking at this, I'm going to say that's 5. And how did I do that? Because this is 3, and this is going to be 3. You'll notice that 3 is the same as this jump, or the number out here. So this is going to be 1 mark for getting a t-chart like this. The second one is going to be graphing this. So how do I graph this? Well, I know that each one of these is a point. So this is the point 0, negative 4. Well, if this is x and this is y, 0 in the left, right. So I'm going to be floating right in the middle, right on this line. And minus 4 is going to be down here. So this is the point 0, minus 4. Now, I'm going to put this next point on. So 1, so I'm 1 step over on the x. And then I'm minus 1, so I'm about there. Then the next one is 2 and 2, so I'm over 2, and I'm up 2 as well, right about there. And you can see that's starting to line up, and we could even put 3 and 5 on that, so it's something like that. And you can draw that graph with those points on it. This is the point 1 and negative 1. So to get full marks here, this is the graph that you'd have to draw. And this is the t-chart that you'd have to draw. So this is 1 mark, and this is 1 mark. These are both really important pieces, the graph and the t-chart. So let's try this again, but let's try it for a harder question. Something that you've maybe never seen before. 27 and 28. You use the same kind of logic. So I have the graph y equals x squared plus 6. Now in these questions, I'm going to say that you must do a t-chart, but you also must do negative numbers. So you can start with 0, 1, and 2, but I'm also going to make sure that in the questions you do negative 1 and negative 2. We have to see all of those things because you have to see what happens to them. So let's start with 0. That's always the easiest one. 0 squared. That means 0 times 0. 0 times 0, well, that's just 0 plus 6. This is 6. Now, let's start with the positives and keep going through that. So 1 times 1. So what's 1 times 1? Well, that's just 1 plus 6 is 7. So that's 7 there. Now, what if x equals 2? What's 2 squared? That means 2 times 2. So 2 times itself, which is 4. 4 plus 6 is 10. So this is 10 here. Now, what about negative 1? This is where things get a little tricky. A negative times a negative number, negative 1 times negative 1, is positive 1. And you might be like, what? But that's just like a rule. That's a rule in math. A negative times a negative. This number times itself, if it's negative, just becomes a 1. It becomes positive. Plus 6 is going to be 7. So look and see that this actually changed quite a bit. Like this is like going back up. So it's like this was going up, and now this is going up. So like that's the lowest point. So this is going to look a little bit different. And let's do minus 2. So if we do minus 2 times minus 2, we actually get plus 4. And plus 6, carrying on down, is 10. So that's 10. So you can see that this is starting to like bell out. That's the lowest. So that would be worth 1 mark. And then if we graph this thing, so we've got 0, 6, so that's way up here. 1 and 7, that's a little bit here. We got -1 and 7, that's here. Okay, this isn't looking at like anything that we've had before. What about -2 and 10, that's like up here. And then +2 and 10, that's like up here. So if you actually draw this, it's like a big bent line. This is called a parabola. This is the kind of line that we're learning in grade 10. It's a bent line. It's the way gravity works, and that's the way this works. So this is the lowest point, and it goes up from there. You might think this is a little wacky, but as long as you do the t-chart and you graph that appropriately, and you make sure those negatives turned into positives when you multiply them together, this is what you should get. So keep that in mind for the future. The other question that you want to t-chart this, and you'll get a parabola for this question. You'll get a bent line. So that's 28 and 29. And then question 29 and 30. So 29 and 30. What's the m value and what is the b value? I'm going to spend a little bit of time on this. When I have y equals 2x plus 1, y equals mx plus b is how this is written. Y equals mx plus b. This is a thing, this is a thing. We don't know what they are, but we call them m and b. B is the easiest one. B is a point where this second value hits the y-axis. So if I'm going to graph this from the equation, I would say that this is B. So I could do a t-chart to graph this. But we're actually being asked what the equation is. But I'm going to show you this first. B is +1. That means that is where on the y-axis it hits. If I change this to -3, then it wouldn't hit here. It would hit at -3 all the way down there. So depending on this b value, that's literally the point on this center line where the graph is going to go through. So we don't know the shape of the graph or which way it points yet. That comes from m, but we know just one anchor point. So I'm going to leave that as -3 and then 2x. So this point is b, and b is always the point 0, b. So think about that for a second. So if b was 10, it would be up here, so it would be 0, 10. If b is down here, it's 0, -3. We always know one point on this graph based on what's called the y-intercept. It's where the line hits the y-axis. Now, m is a funny thing. It says m is the up-down divided by the left-right. What do I mean by that? Well, in this case, that means I go 2 over 1. So I go 2 up, and if it was negative, it would be down, but it's 2 up. So I go 2 up, and then I go 1 right. So that 2 tells me I go 2 up and 1 over. And this is my second point. And this is the point that I get connected to m. And so m is the amount of up-down over the amount of left and right. So since I now have 2 points on this graph, I can graph this thing. So first things first, start with b. Start with this second value and put it on the y-axis. Then for m, figure out what's the up and what's the left and right. And in this case, 2, the only way we could get 2 was to put 2 over 1. No other values would do that. You could say 4 over 2, but that just reduces to 2 over 1. But 4 over 2 would just be this point up here. So we would have gotten this line anyways. So as long as the up divided by the down, or divided by the left rights, is the same as this number, that'll give you the same graph. So in the question that we're given 2 points, and we want to remember the m and the b. This is the slope, and this is the y-intercept. So in the graph, there's a point at 0, -2. I also give a point here at 1, 0. So that means 1 to the right, 0 up, down, so it's along the middle. The b value you can instantly get. So if I'm going to write out this equation, I don't know what m is yet, but I can say blank x. Now, the b value is this. It's where this hits. And remember, we said that this second number, 0, comma b, is always b. So I can say -2 because it's down. So b is -2, and I pulled it from this point where it hit on the y-axis. Then m. Well, how much did I go up to get to this point? So I went 1, 2 up. And how much did I go over? I just went 1 over. So it's the up, down, right, over the left, right. So up over right is the same thing as 2 up over 1 right. And so you can kind of count the spaces up, you can count the spaces over, you put them in here. 2 over 1 is the same thing as 2. So for question 29 and 30, the b value is -2, and the m value is 2, because I went up 2 and 1 over. That is the equation for the graph, and the answer is question 29 and 30. If you get both of those, you get 2 marks for it. And I would give you huge props that you've figured out how to calculate slope, or how to calculate m, and how to calculate b. So that's everything. I hope that is helpful, and I will leave it there. Thanks very much, folks.